Dr. Miller.
They are among the best
I'm Satyan Deb.
and brightest in their fields.
Hello, my name is Jack Morgan.
Distinguished researchers whose discoveries and developments
I'm John Hall.
are making a significant difference in our world today. These are recipients of the 2010 CoLabs Governor's Award for High Impact Research.
The most difficult problem of making a vaccine for wildlife is you get one shot with them. So you have to develop a single injection vaccine. Most vaccinologists don't even want to try that.
Dr. Lowell Miller not only tried it, he succeeded in developing this first of its kind single injection contraceptive vaccine for wildlife.
This is a GonaCon sample.
The GonaCon immunocontraceptive vaccine is registered with the EPA to control white-tailed deer populations, and tests show wide-ranging effectiveness.
We've tested it in bison to help control the spread of brucellosis. It worked. We've tested it in California ground squirrels in a park situation, and it was effective there. We've tested it in prairie dogs.
GonaCon is a non-lethal animal population control method. It can slow the spread of disease and help limit damage from wildlife-human encounters.
Every area has its own animal problem. We have coyotes down in Denver that are causing problems. You don't have the white-tailed deer problem. When you're dealing with an animal that reproduces once a year, it's difficult to get this research done fast because you've got to have multiple years of research. And so it took well over a decade to get this product done.
Lowell Miller and his team at the National Wildlife Research Center took on what seemed inconceivable: to manage wildlife with a single shot that would last several years. They achieved that goal and are now working on the next generation of GonaCon.
The future of GonaCon right now is development of an oral vaccine.
It really makes contraception a viable wildlife management tool, and it's not something that's in the future anymore.
I started on this idea when I was with the industry back in 1960s.
Dr. Satyan Deb had an idea
My first patent was issued in early 70s.
to use a small electrical charge to change the transparency of glass.
Sometimes technology, you invent something and it remains dormant for a while and it comes back.
That technology is now changing the face of energy-efficient building around the globe.
And that will make it change its tint from almost glass clear to a very dark state.
So we put a thin film device on top of the glass that can go from a transparent state to either a reflective or an absorbing state.
Electrochromic windows allow natural daylight into a space, but can also darken to lessen heat gain and glare.
You can save enormously in heating and air conditioning, and also it creates a very nice environment for work.
Now, Dane Gillespie and fellow researchers at the National Renewable Energy Laboratory are advancing this energy-saving strategy with plans to enhance smart windows with photovoltaics for power.
That's my biggest satisfaction. There's something I dreamt of, I worked at it, and it took so many years, but finally it is making a big impact. And hopefully it will continue to make even bigger impact in years to come.
I think we're at a point now where the questions that people are asking come from a realization that not only is climate change a possibility, but it's a reality, and it's happening right now.
Climate change is something of a passion for Dr. Jack Morgan.
And we put down 30 experimental plots over an area of about 10 acres.
And then here's the tube number.
He has spent 2 decades in the lab and out in our native grasslands researching how rangelands respond to increasing levels of atmospheric carbon dioxide.
We know that some plants are more sensitive to CO2 than others. And because of that, we think species changes are already happening in grasslands around the world.
Dr. Morgan and his team from the Rangeland Resources and Soil Plant Nutrient Research Units confirmed changes in our native plant species.
It goes down into the ground and it takes photographs of the roots.
They also found rising carbon dioxide levels are increasing photosynthesis. Plants are growing more but using less nitrogen from the soil, which means they may be protein deprived.
Therefore, they may be less useful for the livestock and also the native grazers that graze and rely on those plants.
This finding is sparking similar forage quality studies abroad.
If you see that in one experiment, it's an interesting finding, but you start to see the same pattern repeated in 3 or 4 different experiments in different grassland ecosystems around the world. Then you begin to believe that, yeah, this is a pretty general and important phenomenon.
We've been getting international recognition. Our projects are one of just a handful in the world, which is something to be really proud of.
Jack Morgan hopes this work will better inform the public and decision makers as they prepare for climate change and its impacts on our plant ecosystems.
So that ranchers and public land managers and the Forest Service and the Bureau of Land Management can use this research to help craft management strategies for the future.
It's just unbelievably unexpected terrain that one has created by this extreme nonlinearity.
Dr. Jan Hall is a pioneer in the field of laser technology. He started this work back in the 1960s and retired a few years back, but he shows no signs of slowing down.
It's true. Retirement is a time to learn some new things.
2 decades ago, a colleague approached him with a concept: create a comb of millions of colors of laser light with each color a distinct frequency. Dr. Hall was an instant skeptic.
I said, Ted, this is absolutely goofy. You're talking about angels on a pinhead, but in modern language. You're talking about something which makes white light repeating pulses of high power, and it's in a collimated light beam. We don't have that. You're talking about something which makes broad spectrum by connecting all these together. We don't have that. And you're talking about some precision of multiplication, which wouldn't be there if you did this, because there would be a little bit of jitter in this.
The impossible became possible with sapphire to focus the light into a synchronized, powerful pulse and a special fiber to create the white light spectrum.
But now it's caught in the fiber, can't get out, goes at the same speed, so they all interact with each other. You put in a wave that you can't see, and what comes out completely white light. It's just breathtaking. It's called magic fiber.
The optical frequency comb is allowing for faster, more precise measuring capabilities.
They make measurements across the San Andreas Fault, and they're trying to see if it's stretching.
It's changing the international system of measurements.
They want to measure the gravity of the surface of the Earth.
And inspiring medical breakthroughs.
One of the most interesting things that's come out of this that will touch every one of your viewers' lives within 10 years, I would estimate, is the possibility to make medical diagnosis.
Nobel Prize-winning physicist Jan Hall is continuing to refine laser precision technology, now with his sights set on outer space.
Life in science is one of the biggest joys that one can have, I think, because the connectedness that one has in experience and in nature is just unbelievably rich. And the more that one learns, the more you see that something which looked like a little blur is actually a piece of Velcro ready to stick your knowledge onto where the rest of this universe stuff is. And in this kind of a way, one builds up a network of understanding.
They are scientific visionaries who endured the frustrations, evolved their ideas in Colorado's federal labs, and improved our world. They are this year's CoLabs Governor's Award winners for high-impact research.
Thank you very much. This is a neat opportunity.
I really and truly appreciate this. Thank you.
It's an incredible honor, and I am deeply humbled.
I am astonished to be given an award for doing something that I love to do.